Okay, now we're doing section 5.6, question 17. We have to find evaluate that integral. And let's see, we'll use u du substitution, and we'll let u equal the cosine of 2 theta. So du will equal minus sine of 2 theta, and then by the chain rule the derivative of 2 theta is 2, and we still have our du here. So, excuse me, d theta. So isolating sine 2 theta d theta, we get negative du over 2 equals sine 2 theta d theta. Now we have a perfect fit. There's sine 2 theta d theta. We can substitute negative du over 2 for that. Next thing, let's change the limits of integration. So u of pi over 6, replacing theta with pi over 6, 2 times pi over 6 is pi over 3, and the cosine of pi over 3 is 1/2. And u of 0 equals, and replacing theta with 0, we get cosine of 0, and that's 1. So now we can rewrite this integral in these terms. The integral from 1 to 1/2 of negative 1/2 u to the negative 3 du. And I can put that negative 1 out front, and that equals negative 1/2 out front, 1 from 1 to 1/2 of u to the negative 3 du. Now, let's evaluate that. We get negative 1/2, and the integral of, or the antiderivative of u to the negative 3 is going to be negative 1/2 u to the minus 2, and we're going to evaluate that from 1 to 1/2. And let's check that out. If we take the derivative, we bring the negative 2 down. That's a negative times a negative is a positive. The 2's divide out, and we get a negative 3 here, so we've done it right. Now, I'm going to bring these two out, and we get positive 1/4, and u to the negative, negative 2, replacing that with 1/2, we're going to get 1 over 1/2 squared is 1/4, and minus, and replacing u with 1, we just get 1. Well, it turns out this is 1/4 times, and when you invert and multiply, you get a 4 minus 1, and that equals 1/4 times 3, which equals 3/4, and we're done. Well, now we're doing question 67, and we have to find the area between these two curves. So we want to know where they intersect. So I've graphed y equals x squared, and that's this curve right here. And I've also graphed this curve, and it's this. We know this curve opens down because the coefficient on x squared is negative. When we factor this, y equals, and I'll factor an x out of both terms, and I'll get a 4 minus x, swapping the two terms. So we've got a 0 at 0 and a 0 at 4, and so the axis of symmetry will always be halfway between, so we'll evaluate this for 2, And when we do that, we get 4. When we evaluate this for 2, we get 4. So the area is enclosed by the two curves, is enclosed on the interval from 0 to 2. So we'll integrate this from 0 to 2, and the top curve is, and I'm going to write it 4x minus x squared, and then from that we're going to subtract the bottom curve, which is minus x squared, and then dx, and so this equals the integral from 0 to 2 of 4x minus 2x squared dx, and that equals the integral 4x, the antiderivative of that is 2x squared, minus, oh boy, 2 over 3x squared, and we're going to evaluate that from 0 to 2. If we take the derivative of this, and boy, that should be a cube there. Bring the 3 down, they divide out. This will become x squared, and we have a coefficient of 2 left. So now let's evaluate that, and we get 2 squared is 4 times 2 is 8, minus 2 cubed is 8 times 2 is 16 over 3, and then evaluating for 0 we get nothing. So this is going to equal, when we get a common denominator, which will be 3, we'll get 24 over 3 minus 16 over 3, which equals 8/3, and we are done. Well, now we're doing question 95, and we have to find the area that's enclosed by the graphs of y equals x equals 2, and y equals 1 over x squared. Well, here's the graph of y equals x, here's the graph of x equals 2, and here's the graph of 1 over x squared on the interval where it intersects with this these two lines. So now we're talking about this region right here, and let's find the area of that region. So we're talking about the integral, and we'll evaluate from x equals 1 to x equals 2 of, and what's above, well, y equals x is, so x minus, and what's below the curve, 1 over x squared dx, and we accommodated for this line x equals 2 when we, that's one of our limits of integration. So now that equals the antiderivative of x is x squared over 2 and plus 1 over x. Now to check that out, take the derivative of this, reduce the exponent. This would be x to the negative 1. Reduce it by 1, you get x to the negative 2, which is 1 over x squared. And when you bring that negative 1 down, it becomes a negative. So we've done that right. And we'll evaluate from 1 to 2. So now, replacing x with 2, we get 2 squared is 4 over 2, plus 1 over 2, minus now. Replacing x with 1, we get a 1 over 2 and a plus 1. So this becomes, 2 goes into 4 twice, this is plus 1/2. Now distributing that negative, we get minus 1/2 minus 1. So these 1/2s add out, and 2 minus 1 is 1, and we are done.